Next, we're going to look at a second method for finding the inverse of a 2 by 2 matrix. This method is nice because it works no matter what size our matrix is. Here's what we do. We form an augmented matrix. This is actually given a special name. It's called a super augmented matrix. And what we do is we put the entire identity matrix on the right-hand side. And we're going to row reduce until we see the identity on the left. What will be left over is our inverse matrix. So we're going to work with this matrix that we started with. We had 1 half, 1 half, 2, 6. And we're going to find the inverse using this method. So we stick the entire identity matrix on the right of the augment. And we row reduce just like normal. It'll apply to both sides of the augment. Okay, so first off, we're going to make our pivot equal to 1. So I'm going to multiply row 2 by, or row 1 by 2. So we get 1, 1, 2, 0. Then we have 2, 6, 0, 1. Next up, we're going to replace row 2 with row 2 minus 2 row 1. Because what we're trying to do is get rid of this entry below our pivot. Okay, so we do our recopying. We get 0, 4, negative 4, 1. All right. Next, we're going to make this pivot equal to 1. So we're going to multiply our second row by 1/4. Okay. So this gives us 1, 1, 2, 0, 0, 1, negative 1, 1/4. And last step before we get to the identity matrix is we want to clear out this value above our pivot. So we're going to do that by subtracting row 2 from row 1. So row 1 is going to go to row 1 minus row 2. Okay. So we end up with 1, 0. Oops. This one we're going to do slowly. Okay, so we have 2 minus negative 1, or 3. And we have 0 minus 1/4, or negative 1/4. And then we just recopy, just like normal, our second. Okay, so this produces A inverse, which is equal to 3, negative 1, negative 1/4, 1/4. And that is exactly the matrix that we found before. So this is an alternative method. You're welcome to use either one. We're going to use this method in the 3 by 3 case and the 4 by 4 case. It's a little tedious, but it's easy at least.